All right, looking at number 19, f of x is a quotient function here, 1 plus tangent of x over 1 minus tangent of x. Boy, and I'm trying to think if there's any, no, Pythagorean stuff we could mess with. I think we're going to deal with this one directly. So here we go, f prime of x, let's go get it. F of x is a quotient, two different expressions that both involve an x, so we're going to go ahead and do the quotient rule. Denominator now, 1 minus the tangent of x, multiplied by the derivative of your numerator. So the derivative of 1 is 0, you can ignore that, and the derivative of tangent of x is going to be secant squared of x. So that's bottom times derivative of the top, minus the top, 1 plus tangent of x, multiplied by the derivative of the bottom. And again, derivative of 1 is 0. The derivative of the opposite of tangent of x is going to be the opposite of secant squared of x. And as I've said before, you really want to put parentheses right there. Otherwise, take a look at what it was before. It looked like a subtraction expression if there were not parentheses there. So that's minus top times derivative of the bottom. All over the bottom, 1 minus the tangent of x, quantity squared. So I don't know, with all that similarity between the first term in the numerator and the second term in the numerator, I think things are at least going to combine and maybe even cancel each other out. That's what I'm really hoping for. So let's see what happens up on the top. It's a little ugly, guys, but what we are dealing with right here is a binomial multiplied by a monomial. So that's just the distributive property here, kind of done in reverse. So that is going to get us a secant squared of x, and then minus, whatever order you want to do this is fine, tangent of x times that secant squared of x. Now, tricky here, guys. I'm distributing a negative secant squared in there, but also there's this minus out in front of the whole thing. So if we see this minus and this minus, they really just cancel each other out and both become pluses. That's probably the easiest way to think about that. So this is now secant squared of x times 1, positive. So plus a secant squared of x, and then it looks like we've got a plus tangent of x times the secant squared of x. And the denominator, I want to stress this again, guys, never, never, never expand that denominator right there when it gets squared. Leave it in factored form. There's never, that I have found, any benefit to expanding that denominator. The best thing that could happen is something would cancel out with the numerator and denominator, but I would need my denominator in factored form in order for that to happen. Speaking of things canceling out, let's take a look at our numerator, and sure enough, one of the things I was hoping for is right here. We've got a minus tangent of x secant squared of x plus the exact same thing. So adding two opposites, those are going to cancel each other out. And that's going to leave us now with secant squared of x plus another secant squared of x, which will be a 2 secant squared of x in the numerator, all over a 1 minus tangent of x, quantity squared. And I would not be surprised if a whole bunch of us stopped at that point right over there and said, woohoo, I'm done, and then maybe went and looked at the solutions manual and maybe got a little bit sad. Maybe you cried on the inside or maybe the outside too if you had something different. My thought was, everybody, now that I'm looking at the solutions manual, that is their answer. My thought was to maybe play around with our Pythagorean trig identities to see if there's anything we can do with secant squared. What I'm hoping you guys all remember is that, let me do kind of a quick abbreviated version of this, sine squared of an angle plus cosine squared of the same angle is always equal to 1. And then, if you divide every term here by cosine squared, you end up with another Pythagorean identity. Sine over cosine is tangent squared of your angle. Sure, theta, there we go. Plus, cosine squared over cosine squared is equal to 1, and then 1 over cosine squared is equal to secant squared of the same angle. Okay, and here's where we ran out of luck here, guys. I was hoping that secant squared would maybe be replaced by a 1 minus tangent squared, but nope, it's tangent squared plus 1. So nothing actually cancels out even if we were to replace that, and that is why the people who wrote the solutions manual apparently actually know what they're doing, and this is the right answer here, guys, and I don't believe it gets any simpler than that. Our derivative is 2 secant squared of x over 1 minus tangent of x, quantity squared, and that's number 19.